Assalamualaikum. My name is Muhammad Amirul Hafiz bin Kamarul Azmi and my ID is MH19013 and I want to present about the introduction. Many manufacturers are now working on a new model design of product that has a higher load capacity and a more appealing appearance. Students were assigned duty in this finite element method project to study the maximum load that the model can bear, the position of the design model failure, and the height displacement, stress, and strain built up in the system. The next step is to modify the design so that deformation, stress, and strain performance may be improved. Autodesk Investor Nasran will be used to perform this experiment. Next, for the project background, student will create a simple model in Autodesk Inventor Nasran and stimulate it. The system will be subjected to standard material load and boundary condition. The integrity of the both basic model in then assessed in the term of first maximal load if can bear and failure location. The most significant relocation, the system becomes stress and strain. Okay, next, for the objective, design and stimulate the sheet metal gripper for vertical lifting in Autodesk Inventor Nasran. The sheet metal gripper vertical lifting integrity will be investigated in terms of the greatest load it can sustain and the point of failure, the product largest displacement and stress and strain in the system. Lastly, to enhance the deformation stress and strain of the previous sheet metal gripper design for vertical lifting. And lastly, for the literature review, engineering analysis is an important application of CAD software. Engineering analysis is the process of determining the functionality of a design project. Almost all engineering design projects necessitate some form of analysis. However, CAD analysis has its own importance, such as improved accuracy. In such a case, the testing phase may reveal that some parameters have overlooked, resulting in structural failure. The use of technology is used to overcome such obstacle. Next is affordable and faster design cycle. That's all from me. Thank you.
So my name is Hani Brenda and I'll present to you parts, materials and pre-processing setup. So for parts, there will be 6 parts, which is bottom bush gripper, inner jaw clamp, outer jaw clamp housing, joint housing, and the locking pin, also the top bush gripper. So for the material used is a bottom bush gripper and top bush gripper has the same material, which is natural rubber, but for inner jaw and then outer jaw clamp housing, joint housing, locking pin, and it uses the carbon steel. So for the pre-processing setup, there would be a few steps. So we're doing for the jaw, so it will have 8 steps. So the first one would be Inventor Nastran is used to open the component jaw, then choose the Autodesk Inventor Nastran from the environments drop down menu. So second is by setting the SI unit. Third step is choose the steel carbon materials for the clampers, and then fourth is by setting the idealizations. Fifth is mesh setting, 6 constraint, 7 load setting, and lastly would be the analysis. So that's all.
Hi, my name is Muhammad Hafiz bin Abri. My student ID is MH19004. I'm going to present methodology part of our project. So this project is about to develop a model with 5 different parts and then test the model using Autodesk Inventor Nasran. We are going to use a finite element method approach. The analysis consists of few steps such as displacement function, strain displacement, and a stress and strain relationship. After design a new part, it will improve performance in terms of deformation, stress, and strain. So this is our model part. First is inner jaw clamp. Is for houses the bottom bush gripper and keep the top bush in place. Second is outer jaw. It is used for housing for the inner jaw clamp, the top bush gripper, and bottom bush gripper. And next is bottom bush. It is for gripping the bottom part of the metal sheet. And the top bush is for gripping the top part of the metal sheet. And the last one is joint housing and locking pin. Joint housing is to allow the gripper to slide and clamp the metal sheet, while locking pin is to lock the component of the gripper in places.
Hello, good morning. My name is Geraldo Ispirin. I want to present my part, which the result and discussion before improvement of one message stress for each part of our project. So the first one is, what is one message stress? So one message stress is equivalent stress value based on strength, shape change, and energy used to determine if metal or other metal begin to melt. And what is actually the criterion? So a metal will flow if the one message stress under load equal or greater than yield strength under simple tensions. So next, we also measure the before improvement of displacement of each part. So what is the displacement? So displacement is distance between an object and a particular reference point. So we use finite element analysis, which is the FEA, the coordinate system, and we use the length unit meter in m. And what actually we measure? So we measure the minimum and maximum displacement value for each part. And then next, this is the after improvement we make. This is the drawing in SolidWorks that we get. And then next, so this is the stress result comparisons before and after. So the first one is the maximum is 9.267 exponent positive 5 megapascal, and the minimum is 3.023 exponent plus 0.6 megapascal. So after, the maximum is 1.749 exponent plus 6 megapascal, and the minimum is 1.349 exponent plus 4 megapascal. And also, this is the strand result comparisons for, we only take is the conclusion for project. So the conclusion is the engineering project report will require an assessment of a sheet metal gripper that is our product that we choose to complete this project. And then in term, we analyze in terms of stress, strain, displacement, and the application generated 5 sub product that needed to be analyzed. And then the all product component were we designed using SolidWorks software, and the carbon steel and natural rubber were used to create a material with a real-time characteristics. And we also find out what the ideal criteria for sheet metal gripper will be in terms of greatest load it can withstand and location of the failure, if either high displacement and stresses and also the strength built up in the system. And then using simulations and analytical software and a design improvement will be made to increase performance in terms of the deformation, stress, and strain. Thank you. That's all from me.